So I had to make this little item. It was a plug socket pin out of a 3-pin socket. Oh, focus is bad. And I got thinking to myself, when this lathe is up and running, there may be some celebrations required, and there's nothing better than football stadiums for celebration, so I thought I'd make a football stadium. So I'm making a terrace right now, and I'm going to put the seats in soon, and then all the people can sit down there and cheer and wave at the things that are going on in front of the lathe here. There's the old backsplash. It's pivoted into a position. I've welded up some bits of steel and it's nearly finished. It's work in progress. There's going to be some kind of cover here which you can lift up to get down to the handle at the back there to change the gears. It's not finalised yet, and the tool posts are up there just holding the weight on to keep it nice and square. Anyhow, that little copper item that you see I've just made there, that is the copper wiper which is going to go on the bottom of the thing, you know, the carriage lock stop thing. You know, you put it in position and it locks it on, and that's what it looks like. It's mint, basically. I like to play my own trumpet, but I've made a really good job of that. It's got M7.5 threads in it and an M6 lock bolt. At present I'm just going to use a stainless steel lock bolt. As you can see, it's just got a stainless steel lock bolt in it. And when I get round to it, I'll make a quick release handle. And when the lathe's running, I'll make a M7.5 micro adjuster. This little thing here is going to go right in there. Show you where it's going to go. It's going to go right there, like that. So that'll be in there, and that will wipe and break across the bottom of the bed here. It'll put the finger in there. There we go. It will touch up here, and it will stop the clamp from wearing out. So just have to replace that when it wears out. And I suppose I'd better show the fit. I got it this good. Can we come out of the lighting isn't very good in here. Anyway, it touches both prismatic ways, and when the wiper goes underneath it, it will lock up beautifully. It pretty much fits how I wanted it to. It's about 1/4 mil high. It's not quite level with this, but if I put a 1/4 mil sheet of steel across that, it will be level with that. And it's more or less parallel with the edge as it comes out, so it looks like it was made to fit, basically. Oh yeah, and then this. So this is the apron. You might not recognise it, but this is the apron. So I had some steel, 4mm steel I think it is, and I cut that out by hand, and then I've just milled the top, and I've milled the bottom flat, and I've just kind of slotted it. And when I was milling it, plan of action was to come to the top and then just to mill in a little bit this little bit here, and then jump across and then mill in that side there, but I am doing all this on the micro milling machine and it didn't have enough travel, so we'll see how it goes. This piece here is going to be folded up, so it will go in there like that. It will be in that way, so when this gets folded up like that, it will be above the lead screw and below the rack, and it will stop chips getting in here. So there'll be a little blanking plate at the top. There'll be a bit at the top which is sealed it off, because the top will be sealed from the touching the saddle, and there'll be a bit across the top there, and then there'll be a bit flapped out like this, so any chips will be hitting the thing and falling off down here and not going into that area. The steel plate, I'm going to be putting M3 screws. I'm probably going to be putting quite a few in here, probably one here, maybe one in the centre and one there, and then one at the top there and one at the top here. So I just want a good seal around here. And today I cleaned it up on the mill. It's got some filing to do around here to make it absolutely fit beautifully, but it's there. It isn't quite flat, so there's some tweaking to do for it, but it's looking okay for a piece of steel which I found in a car going for scrap. It's been used as a floor mat. They were cut perfectly to size for floor mats for that particular vehicle. But yes, someone had made steel floor mats, smooth steel floor mats. Who knows why? And there's going to be obviously the steel thing in that last cutout thing here. So this cutout that you see at the back here, there's going to be a steel plate coming out here where you can put a mag base on. And there might also be one on the carriage. I think I'm going to put one on the carriage for sure. And that will kill two birds with one stone actually. So if I just drill and tap two more holes here, two small holes, one on the side of the prismatic ways, have the piece of steel go all the way down here, and then spread out around here somewhere, just missing that, and have it here. And I might do away with the piece of steel on there if this one clashes with that one and this one's more useful. And this piece of steel, actually, thinking about it, is probably going to be a cover. I might make a cover to keep the chips out from here. Right, I'm coming along with this bit. I first roughed it out with a plasma cutter, then I squared it up and cut in the bits with a milling machine. Had a great big accident with a milling machine where I caught it here and it folded that into, well, that was all different shapes, that was. So I straightened it back up again, but that was bent over at 90 degrees. You can probably see a few marks of folding. If I point out, there's a divot where my thumb is. You see it now? The light's just divoting in there, yeah? Okay. This scratch was here already before, that scratch was there before, and this is being used for, this is second-hand metal basically. Anyhow, I straightened it back up again and it's pretty cool. And then I thought, well, I'll try milling that slot out. And it went brilliantly. Couldn't believe it, that small little cutter went up there and down there. And now I'm just setting up for drilling those holes. So I've got a 40mm centre on the left there and a 15mm centre on the right there. And they line up with those holes there. Obviously those are already there, existing for the steady rest, and then these two aren't here, so I'm going to have to drill and tap those. This is going to be a little shield for the front there. Okay. Then the lock, I've decided against moving it. Would have been a better thing not decide against moving it. Right, so I've decided against drilling here and drilling here to fix it. So that would have been drilling and tapping here, a bit of a spacer there. Not happening anymore. What is now happening is I'm going to cut out that, so we can see that. Yeah, can you see the hash marks and what have you? I'll try, there we go, so it's like another T. And that is going to sit in there. I'll show you. So that's going to sit in there. And then there's going to be a couple of holes in it, and they'll be drilled and tapped into the front there. And there's going to be another hole in the bottom, and that'll be drilled and tapped into the T-slot, into the carriage lock. And that will hold it, and that's fanny off of binding, just a little bit. And it'll be a loose fitting, so it'll be a shoulder bolt, and it will just allow a little bit of play. Just a little bit. And I think I'm going to have to put a spring, so I'm going to have to counterbore the hole and put a spring in just to stop it from vibrating, a really powerful spring in there. 2mm wall thickness spring, something like that. Then on the back side, well it stayed in actually. So on the back side, down in here, obviously it was just going to be drill and tap in there, and then you have a little handle here, and I thought to myself, tailstock, tailstock, tailstock. That is going to be in the way of the tailstock. You could just have an Allen key there, it will fill up with chips, it'll be a pain in the arse. So I got to thinking. So then I cut out that disc of steel there, and that disc of steel is going to be like a handgun shape. Okay, it's going to look a little bit like a handgun. So it's going to have a bit which drops down inside there, and that is going to be having a drilled and tapped into the end of it like that. Okay. That unit which goes in there will have another pin coming up here with a taper in it, and then in the gun section, the barrel section you're looking at here, there'll be a ball bearing that goes down into that taper, and a pin inside which goes and touches against that ball bearing, and then a locking handle out here. So you turn the locking handle a quarter of a turn, let's say, it forces the bearing in, the taper on that shaft pulls up, and that pulls up the lock, and that will lock it all. And then it'll be out here somewhere. So if we look at the approximate, it's going to be the full width of that, so it's going to come up to about there. So it's going to be flattened off a bit, so it's going to protrude past the prismatic ways. It's going to be in here somewhere, it'll be above the lead screw I should imagine, somewhere around here. So I'll probably have to extend it with some when the lever's out. I'll make the lever a pretty chunky thing, so it'll probably be out. I'll probably make it so it's level, but hidden behind the carriage here. And of course, that weighs quite a lot at the moment, and that doesn't weigh a lot, but that amount of metal is going to be cut out of that. So this will be adding that much more mass to the saddle assembly. Like I say, after I've done all these modifications, I'm going to weigh how much extra mass has been put into this saddle. And there is a mathematic calculation that you can use to determine how much frequency mass will take out. So the more mass you put in, the harder it is to generate a frequency, because it takes energy to generate a frequency. So you can I'll be able to take deeper cuts, heavier cuts, without getting chatter, so long as these ways are tight. So really it doesn't really matter how tight you get your ways on one of these little mini lathes. There's not a lot of mass there, so you won't be able to take deeper cuts. I'm going to be putting a 1 horsepower motor on this mount, and I won't be able to utilise that because of the weakness of the structure. So once I've stiffened up the bed, which I'm going to be doing, and scraped it all in to make it all nice and straight and everything, this extra mass will really pay dividends for surface finishes and ability of this machine. Right, this is a few more hours work. I have bent that at 45, bent that at approximately, I don't know, 20, just to come level at the bottom of the thing, saddle. But you might have spotted the problem already. This is all loose, the gibs aren't tight to anything. There's clearance down here, which is nice. I'm still going to have to put another shield off of the cross slide over this one, just to make it a labyrinth seal, to keep even more chips out, but that's another thing. So that's the clearance there. Let's see if I can get you around the back. I've milled it so there's clearance, and you can see that there's clearance there. Yeah, I think you can see that now. There you go. Right, so there's clearance for that to go over. Okay, so the final little drama. Plus, when you wind your handle down here, there's any hot chips coming out down here, they tend to hit this and fall away from you. Not all of them hit you, hit that, but a few of them. So I think I might box this in completely. I'm going to be obviously welding the panel in here, stop the chips getting down there, and I think I'll probably just weld a panel in here as well to stop the chips going in here. So they will gather in here, but who cares? I'll just brush them out and away we go again. Like I say, there's just one more thing. The cross slide should butt up against this with full lock. At the moment it's going to get there and it's going to stop. And that's it, it's come to a stop. So I've got to deal with that. Now, I was going to bend this down and then bend it back up again over double 45, if you see what I'm saying, yeah? But that's going to be extremely complicated to do. And then I had the brainwave about 5 minutes ago, just as I was building this up. I thought, you know what, why don't I just bend that back down a little bit, and it might even be perfectly up against that and stop chips going down there. The chips might pile up here, that should be perfectly fine. I might just have to put clearance for the dial so the chips don't grind the dial away, so I might just put a radius in there for it, but that'll be down there and that will stop the chips falling down this way as well. And this is the first piece of metal that I started off with, and that's it. So I've got 2 holes to drill here. I've marked those. You can see the marks down there. So I've got to drill and tap those 2 holes and sort this out here. I've got a pretty pile of parts going together now. The front shield is basically done for the time being. Just got to weld them. I think I'm silver soldering in the 2 little flats here, and I'm going to work on this for a few hours because I've got to hand file that amount of material off there. And then there'll be loads of holes to drill and tap, and I've got this brass washer which I cut off like months ago. I mean, I've got it somewhere, and amazingly the holes boards are exactly the right size, so I'm going to have to tidy that up until it's nice and flat and not so manky looking, and then that can be the bearing for inside. So that's going to be hand fitted as well, because I haven't got a lathe working at the moment, and well, let's face it, could you actually do anything with that on the lathe? I suppose I could glue it onto a faceplate, but I don't have a faceplate. I might make a faceplate just to do that. Oh dear. The fun of having 2 lathes that don't work and needing a lathe to do it. I could super glue it to a piece of aluminium decked off on the mill and mill it to dimension. Might do that. Awesome, eh? Oh, so I've got the stadium, and I've done nothing to that yet. And we're panning down. I'll try. Still a bit of weld going on there. Now we've got the Darth Vader TIE Fighter chip shield going on. You can see all that. Yeah, I think just about there you can see it all. Then I've got this piece of metal here cut out, and this piece of metal here cut out, and it's got a little notch in it. It's all folded out into a round. It's got a curve on the front of it, and that goes in now and welded, although I'm thinking I'm going to silver solder it. I haven't decided, or I might braze it with silicon bronze. And this piece, I haven't finished it yet, I'm just cutting it to size. That piece goes in there. So basically there's a little trap in here, so no chips can go in that way now. That's all. Perfecto, and it strengthens the magnetic base wing thing here. So that's going along. I'm whittling at that bit by bit. Cut them out by hand. Both of those have been cut out by hand and hand filed into shape so far. And I've put the cross slide on, not tight, but you know, it's just on, and the compound on it again, not tight, it's just on. We zoom out. Yes, I'll zoom out a little bit. And that's because I've been squaring up blocks this morning. So, a 9.5mm drill drilled to 10.17, something like that. Quite disappointed at that. Anyway, I've got to put the slots in now. So I've got to this won't make a big clanging noise now. Oh no, it's alright. So I've got to put the slots in now. These slots here. And I don't see there's any point in putting the top land above centre by much at all. And the maximum tool, what do I want? 12mm, 10mm. The more meat I take out of this, the less mass this unit has. So if I make the slot 12mm down from centre and 12.25mm total height, that'll give it a bit of clearance. So my plan of action is to come in up there like that, try not to knock everything off, and scribe a line. I'll try and scribe a line anyway. It's not working how I planned. Hello and welcome again. Now, hopefully this is the last video before I'm actually going to make some chips of this, or the full strip down is going to happen, because my Holbrook lathe, I managed to get it stripped down and get the bearings out, so I can order the bearings and put it all back together again. It's just a matter of getting them and waiting for them. So we're in a fight of tussleness at the moment of what's going to get working faster, the mini lathe or the Holbrook, to make the parts I require to get my workshop built, basically. Anyway, in today's video I've got some machining, because I know the last two videos have just been talking, and I'm going to show you the machining of the plate for the apron assembly. As you can see, it's here, the half nuts work inside it, and it's all covered to keep the chips out. So I've got a bit of footage which will be speeded up footage of me drilling and centering up on the holes, drilling and tapping them and showing you how I did that, and a little bit of me showing you how I got the surfaces of the backing plate here flat enough that they will seal easily with silicone. Fingers crossed. Obviously all this is fingers crossed because I haven't tested this yet, and well, hopefully it's going to be oil tight. A couple of more things. This carriage lock wasn't square, so I've put it back into the milling machine and squared it up, and in doing so made a small little bodge down here. It's not going to make any difference. It is less than 200th of a millimetre, but you can see it. The carriage stop, I can just about live without that, I think. So I'm not going to get that up and running before I do the first project on the lathe, if this lathe is up and running in the next week or so. I've got the first tool holder completely built, it's ready to rock and roll. I think I'll need a wash on top of it to get the angle of the locking lever right, because that's pointing towards the chuck, although I don't think it really matters. I don't think it's going to get in the way, so I'll see how that goes. But that's a twin holder. I'm not sure if you can see that. I'll get some close-ups of that. It only holds two tools, one this side, one that side. And I've got 3 more blocks squared up. Now these are parallel that side to each other, parallel that side to each other, and perpendicular to that face. For some reason, I'm still having a problem on the milling machine. I can't get that face to square up to anything. It just won't. So I've marked it T for top on every single one. These are all different heights at the moment, so they're not coming to final dimension. So maybe bringing it to final dimension, I can get that top surface square. I mean, I'm getting a bit ratty with it. I've tried multiple vices on my Bridgeport, and I just can't do it. So I've got 3 of those ready to rock and roll. They're going to end up looking identical to this, well, almost identical. This one here will take a 12mm cutter, no problem. I think I'm going to make these a little bit more weighty, in other words taking less material out of these, and make these for 10mm cutters, or 3/8 cutters. And if you haven't grasped what I'm doing here at the moment, obviously I'm improving the lathe. For instance, that rear cover could have very easily made out of perspex or plastic and made it in 30 seconds flat, and attached it with 2 bolts and put grease inside it. But I've made it out of metal, which is heavier, has more mass about it. We're getting the mass thing going on here. And I want this to be oil tight, so it can run oil inside of it instead of having grease inside it. Ready to test it now. I'm going to screw it together and do an oil test on it now. These blocks, they've only got 2 slots taken out of them, so there's a cube of steel which is extra mass. There's more mass. I'm getting this. The carriage lock, and this is part of it, there's 2 other parts. There's another piece of steel goes here, another piece of steel that goes here. It's very weighty. Now I could have made a little carriage lock at the side, but this is very weighty and adds more mass. This I've made out of aluminium and copper because it has no effect on the machining of any part. It just is a stop, something the carriage can come up to and stop, and you can adjust it accurately, and that's all it needs to do. So did it need to be made out of steel? No. Aluminium should suffice. Aluminium and copper should suffice nicely. If it doesn't, I'll remake it out of steel. I think it will be fine. But it is ready for assembly once my fixings come for this. So in this video I'm going to show you how I machined all these bits and bobs for this cover. Hope it's interesting for you. Thank you for watching, and I'll see you again in the next one. So the idea of this isn't for a surface finish. I'm looking for a gasket seal all the way around the edge. Not bothered about up here, but around here I'm going to put some black RTV or something like that, and I want to make sure it's going to get a good adhesion. On the outside it was just, I mean, it's been gripped with the vice a few times and so on and so forth. I just wanted to get some of the vice marks out and what have you, so it looks a little bit better, but you're never going to see it, so it doesn't really matter. But there you go. I'm just bringing you in close so you can have a closer look at all this. Let's take this off. I've took my gloves off now, haven't I? And here we go, I'm filling with oil again. Oh well. There we go. I attempted to ream that whole 10mm, but we've got a little bit of play in it. It's not a problem. That's the profile. I'll just put some stainless steel bolts in there to give you an idea what it looked like, or was it to be a plain piece of metal with some holes in it. Try and give you an idea of the finish if I can get the light in it. Obviously inside the slots there I had to use a milling cutter. On the outside I got it fly cut. It's very nice, the fly cutter. Makes it look like a tree, and you can see a couple of dimples in here. That's where I was using the ball bearing to press against it. I'm not fussed about that. Here's a close up of the plate. It's got the two dowels in, they haven't been cut to size yet. So those dowels aren't there to, they're not there to line it up, well they are there to line it up, but they're not there to hold it in line. They are there as datums. I put two in just to make sure that if one didn't go right I could get the second one right. And what I used them for was, this is an uneven surface and this is a piece of steel which was sort of square. And I needed to measure these holes out here and get them, if we can get it out without dropping everything. I thought something had dropped then. Just a screwdriver. And get those holes in that flange. Okay, so I had to make sure I didn't break through and make sure I had a good fixing, and I think I've successfully done that. So again, that's going to have grease in it, that's going to have oil, there's going to be a little oil reservoir in the back, in the bottom here, sorry, and so as soon as the gears start turning they will transfer oil in between each other and it will drip down the sides and everything, and even fall into the bearing area, and it will be good hopefully. And if I keep it topped up it will keep on dripping oil out of that onto the rack as well, so it will even lubricate the rack up here. That's the idea of that. There's the two pins. Obviously they've got to be ground to final length, and you'll see why I needed to use datum, because if you don't use datum and you just do it by eye like I did, you make mistakes like this. Can we see that? So I broke into the casting there. It shouldn't be a problem. If it is, I'll take some measures like building it up with JB Weld and then retapping the hole to seal it from oil leaking. The only thing it can do is oil leak. The bolt's got a really good hold in it. I don't know if you can see that, it's got more than half a, it's got 2/3 of a hole there, so the bolt goes in there and it's nice and tight. I can torque it up with a screwdriver. So not using a datum and just using your eye, those holes really could have done with being about a millimetre further back, but I didn't want to break into that dovetail, you know, I was being scaredy pants. But once I had the datum in, there was no mistakes up here, and this was hypercritical up here. I really didn't want to make a mistake up here. So I took my time and I got it right. And let's have a look at the plate after it's been bent, because obviously you're going to see the machining. Now there wasn't clearance, so from the top it doesn't look too bad. There's a little bit of a rip, it looks like it might have been welded. And the hanging down flappy thing isn't finished yet. There's going to be some trimming probably, I don't know. It might be touching the lathe bed, so I might have to put another bend in it here, just one more bend to bring it down parallel to this surface here, or I might just trim it. But anyway, the half nuts wouldn't operate, so I milled out, and it still wasn't enough. So then I got a punch and I started punching from the back of it to punch it through this way. As you can see, it looks like a weld. Of course that deflected the plate, and hence it isn't quite square anymore at that end. This side of the plate, the important part of the plate's good. And the cover doesn't really matter, but it is slightly bent. Not a problem. There you go. That should work a treat. We're going to find out very, very shortly. Within less than a week, or maximum 2. I'm waiting for these screws down this side here. I've ordered them about 2 days ago. It says they'll be here by the 17th of April, so I think they're already at Hermes, and I got a message this morning from Hermes saying there's a package waiting to be sent out for delivery, so hopefully they'll be here tomorrow, but that's all I'm waiting for that. Then I can rebuild everything. No, I can't. I've still got to do this. Oh my word.